Hi children. അപ്പോൾ നമുക്ക് പുതിയൊരു സെഷൻ സ്റ്റാർട്ട് ചെയ്യാം അല്ലേ? ഇനി നമ്മൾ പഠിക്കാൻ പോകുന്ന ടോപ്പിക്ക് ഇലക്ട്രിക് ഡിസ്പ്ലേസ്മെന്റ് എന്ന് പറയുന്ന ടോപ്പിക്കാണ്. ഓക്കെ, സോ ലെറ്റ് us consider two charged plates. The charge on the first plate is plus sigma. The charge on the next plate is minus sigma. Then what is if E0 is the electrostatic field between these two plates, what is the value of E0? Value of E0 is going to be sigma divided by epsilon 0. It's a well-known idea for you, I suppose. It is E0. E0 is equal to sigma divided by epsilon 0. What I'm going to do next is I'm going to place a dielectric which occupies the space between the plates of the capacitor. What will happen? As a result of placing a dielectric, polarization occurs, and we know that negative charges will be accumulated here and positive charges on the other side of the plate, which in turn, okay, let us take the surface charge densities of the induced surface charge densities as sigma p here. This is minus sigma p and this is plus sigma p, and this will cause an EMF electric field induced in this direction. Let us put it as EI. Now I can write the magnitude of the induced electric field. As you know, it is sigma p divided by epsilon 0. Sigma p divided by epsilon 0. This is the magnitude of the induced electric field. Now the question, if E is the net electric field inside the dielectric, E is the net electric field inside the dielectric, then what is going to be E? Using the ideas of vectors. This is E0, this is EI. Are they in the same direction or in the opposite direction? They are in the opposite direction. Which means the net electric field has a magnitude E0 minus EI. E0 minus EI. Now we have the magnitude of E0 is equal to sigma, this may be, okay, this is equal to sigma by epsilon 0 minus sigma p divided by epsilon 0, which may be written like this. Sigma minus sigma p divided by epsilon 0. Is it okay? Right. But we learnt from Coulomb's law that E is equal to E0 divided by K. Okay, let me put this as equation number 1. E is equal to E0 by K is the net electrostatic field inside a dielectric, which implies, substituting for E0, what is E0? Sigma by epsilon 0. This will give you sigma divided by K epsilon 0. Let us take it as equation number 2. Now we can use equations 1 and 2. Then we can write sigma by K epsilon 0. That is the left side of this. Both the left sides are same. That means the right sides also must be same. Sigma by K epsilon 0 is equal to sigma minus sigma p divided by epsilon 0, which will give you, so both sides we have epsilon 0 as a denominator which can be cancelled. Sigma by K is equal to sigma minus sigma p, right? Or, okay, let us bring sigma p to this side and sigma k by K to the other side. Sigma p is equal to sigma minus sigma by K. That is equal to, sigma can be taken common outside. Sigma into 1 minus 1 by K is the answer. The induced surface charge density in terms of the surface charge densities of the plates are obtained as sigma p is equal to sigma into 1 minus 1 by K. Hope this is clear, and let us take it as equation number 3. This is a very, very important equation. Please understand this. Now the next thing we are going to discuss is what we have discussed earlier, that is polarization. We know that dielectric polarization P is equal to induced dipole moment divided by volume, right? This is equal to dipole moment, induced dipole moment. What is the formula for dipole moment? It's a product of charge and separation between the charges. Let us take this separation is equal to, say, small d. Now charge, what? I don't know charge, I will write in terms of sigma. The induced charge QP can be QP divided by A is equal to sigma P, right? QP is the induced charge. Okay, so I will write as QP into D divided by volume of the dielectric. I told you the dielectric is completely occupying the space between the plates. Which means I can say the volume is equal to area of the plate into length, this length which is D, that is A into D. Which means I can say polarization vector P is equal to sigma P. The magnitude of polarization P is equal to sigma P, which is equal to sigma into sigma P is already sigma into 1 minus 1 by K, or I'll write K minus 1 divided by K. That is another important equation, and let us put it as equation number 4. This is equation number 4. But in the topic dielectrics, we have seen that polarization P, it's a vector quantity, although I am just writing the magnitude of the polarization P is equal to chi E into E. That is equal to E is equal to sigma divided by K epsilon 0. I will write it as chi E into sigma divided by K epsilon 0. Let us put this as equation number 5. Now look at equations 4 and 5. The left hand side is just the same only, which means from equations 4 and 5, sigma by K into K minus 1, which is equation number 4, left side is polarization, that is equal to chi E into sigma divided by K epsilon 0. Which means both sides we have sigma, which can be cancelled. There is another K on both sides, that also will be cancelled. What does that mean here? Left side we have K minus 1. Right side we have chi E divided by epsilon 0. Or that concludes me chi E is equal to epsilon 0 into K minus 1. Chi E is equal to epsilon 0 into K minus 1. This is an important answer. The expression for electric susceptibility chi E, chi E stands for electric susceptibility, that is equal to epsilon 0 into K minus 1, where K is dielectric constant. Now what is the electric susceptibility for a conductor? Electric susceptibility for a conductor. What is the dielectric constant for a conductor? Dielectric constant for a conductor is infinity. That means K is equal to infinity for a conductor. That means the susceptibility of an ideal conductor will be infinity. That means I can again substitute here the net electrostatic field inside a conductor is also going to be infinity because K is equal to infinity. Which means the applied field is equal to the induced field inside a dielectric. Which means whatever be the external field we supply to a conductor, not dielectric, I'm sorry. Whatever be the external field you supply to a conductor, that much field will be induced inside the conductor such that the net electrostatic field inside a conductor is 0. net electrostatic field inside a conductor is 0. I hope you understand this discussion.